My kiddos that are gone today, my 2 that are absent, we don't totally know where you are, but you're not here. And then my cross-country kids, cross-campus discovery, this is me on little science thing. Anyway, cross-campus. No, you're fine. We're going to grade section 7.4. We have to start notes for section 7.5 because we are starting logistic growth. Hold on. 7.1 was like integration review, but like trickier integration, I think. 7.2, wait, no. 7.1 was slope fields and Euler's method. Yes, learned super interesting stuff about Euler at the conference this weekend. Super interesting stuff. But anyway, we just covered it. And not in the place where they would have wanted us to cover it, but that's okay. It's where like most textbooks do. So slope fields and Eulers. Slope fields review, Eulers new. Section 7.2 was integration kind of review, but like tricky integration. 7.3 was integration by parts new. Section 7.4 was exponential growth and decay review. And section 7.5 is logistic growth new. So we need to get into logistic growth today to at least start it. I think we only have section 7.1 to 7.5. I had the calendar up a moment ago, but I think I put it away. And now things are not coming up. But all that to say, I can actually check it here. Yep, this is logistic growth. Woo! Lice minus licht. It's a louse? Is that singular of lice? And it's a cow with his tongue sticking out. Lice minus licht. We need to talk about partial fractions today. And then tomorrow we'll talk more about logistic growth. But anyway, so we have to play a little bit with a little bit of review, a little bit of pre-cal. But then all of it is for the purpose of us getting into this logistic growth thing. Now the nice thing for people who are absent today, people that are absent today, go ahead and follow along with us as far as grading and you grading your homework also. But then tomorrow we will really be digging into this logistic growth. This is just the intro of it today. And I'll take a last call for questions if I don't answer one of yours today. But first, homework. All right. Exponential growth and decay. That's not you. This is you. Here we go. Number 2 and 6. I think you were just solving the differential equation by separation of variables. That sound right? Okay. So you were separating, you were integrating, and hopefully you ended up with y equals the positive square root. Yes. Otherwise, y could not be a positive 5 of 25 minus x squared. Number 6, hopefully you saw that 1 over cosine squared is secant squared, which has an integrand of tangent. That would have made life a lot easier. And then to solve for y, you had to do tangent inverse of x, and your c ended up being 0. This is just them kind of saying the domain or the interval for which this is true, because outside of this interval doesn't exist, right? And then he has a, tangent inverse. What does he look like again? Do you remember tangent inverse? No, careful. Inverse isn't 1 over. It's a reflection across the y equals x line. He's like the cubed root guy.
Oh, are you talking about the graph?
Yeah, the graph. Why am I saying that? What's the domain of tangent itself? Well, can't be at pi over 2, can't be at negative pi over 2, can't be at 3 pi over 2. So many vertical asymptotes, but what about tangent inverse's domain? Why does it say all real numbers? How left, how right does tangent inverse go? Yeah, infinitely. So tangent inverse's domain is all real numbers. Number 10 is another separate. Did you guys get? That 4 does not come in front. Because it's the entire ln of x to the 4th. It's not ln of x to the 4th. It's ln of x, that entire quantity to the 4th power. Just be careful. C was 0. This is just the natural domain of ln, so just discussing for which values this works. Does that mean there's no solution to this in any other interval? Number 22, this was a good old-fashioned exponential decay equation, although I guess they didn't make you write. I guess they didn't. Y would have equaled e ce to the negative, there's your kt. But you had to use your half-life clue. I think there was a clue about half-life. Did it actually say that?
Yes.
Because the half-life is the value of, like, the proportion of what amount you have. So it's not literally how many you have. You have half of what you did have, so that little constant if you integrated would have been on the other side. They didn't really show that constant though, but that c, y over c would have been 1/2, and then you just divide by the time. And this is actually something in chemistry for half-life and doubling. You can actually just memorize the constant k. It's either ln of 2 over how much time it takes to double, or ln of 1/2 how much time it takes to be cut in half. But anyway, there's your k. Number 24. There's your exponential growth equation. Must have been a directly proportional rate. They gave us a number, and it was a big old plug and chug, just playing around with algebra, to be honest, guys. So at the end of the day, the initial population, hopefully you found it to be 1250. And they're talking about like different things that you could notice, maybe some patterns that you could have used instead of just the good old-fashioned plug in, and then plug in, and then do like a substitution, elimination, setting up systems of equations. The nice thing is if you have E over E, because they just took the proportion, or I should say the ratio of one with the other, like, okay, fine, this over this is that over that. Similar or like bases, I should say. You can subtract the exponents, and so that's how they got to here, and ln of both sides. Pretty snazzy. I think I would have used substitution, but that's okay. Number 34. Getting back to your original equation and plugging in chuggy. You should have gotten 1209 for A. For letter B, you would have had to find that second derivative. And then you would have seen that that second derivative will always be positive if W is greater than 300. If W was less than 300, then I would have had a negative. But we were looking just for greater than 300 for the case we were looking at. So since the second derivative is positive, the original function is concave up, which means the tangent line is below. Underestimate. In letter C, we're actually solving a differential equation. Did you guys divide by W minus 300? It's the only way to go. Had to use ln's at both sides. You had that little constant come in front. They renamed the plus C like an A. Totally fine. It technically is not the same number that's in front. It's e to the c, which is some new constant. And plugged and chugged, A ended up being 900, and that was your final solution to your differential equation. Whew, finally, we got there. That was a little rough. So, is there anything in particular that you guys are like, help? Maybe odds first. Any odds that you were able to check and you still weren't able to make it match?
7.
7, okay. Any other odds specifically? Oh, number 7's on the next page. Okay, then I'll ask about evens in just a second, but let's go peek at number 7. Number 7 is one of those, he's up here, solvey ones. Ah, but he's top-heavy. What? We haven't seen top-heavy ones in a while. See if my snipping tool gets up. So as you guys are looking at it, I mean, you can see the answer, and you were able to see the answer in the back of the book too, but how did they get there? Well, could we let the denominator equal u? I think that's number 7. Is that number 7? Section 7. Oh, wait, that's 7.5. Sorry. Oh, I was ready to have fun with that one. Okay, alright, never mind. I didn't think we talked about improper fractions yet this year, but I was ready to go. Okay. Just kidding. Okay, you're trying to go backwards from this dude. Oh, he's even easier. I mean, he's not easy, but he's more straightforward. We're going to multiply both sides by a dx, yeah? And then, who's your u? I'm guessing we're finding a solution to the differential equation. I didn't actually watch. Read the directions. Yeah, separation of variables. Okay. Who's your u? There's only one thing it can be, guys. Yeah. Some of you might be thinking integration by parts, but pause. Don't we kind of not mind the cosine x? Wait a minute, what's weird though? there's a y and a sine of x. Question, what is my integration constant, not constant, variable? What's the variable with respect to which I'm integrating? So technically, am I allowed to leave that y where it is with the math that we have done? Or the math that we know? Am I allowed to remain there? I can't integrate an expression in terms of y with dx. So if that's illegal, is there a way to split that guy up at all? Nice. Addition in exponents is the same thing as x to the a times x to the b is what comes out of x to the a plus b. Exponent rules. Who knew they'd be so hard? That addition can split up to be multiplication. And so if I can rewrite this to be e to the y times e to the sine x, who gets to say? Who has to move? So I'm going to end up with dy over e to the y equals, well, that just got a lot better. First of all, it's legal for me to integrate now. Although this is going to be something that a lot of people miss, because you can't integrate 1 over e to the y, but what can you integrate? E to the negative. So rewrite that with, once again, exponent rules. If he's down there and you want an e to the u, we'll get him up there and make him an e to the u. He's just going to be a negative one for that u. And then over here, I mean, technically you would think about this as a v, I guess. E to the v, and then this one's like an e to the u. You have to solve them separately. But now this is legal for us to do, because over here we could think of, hey, is this going to help your abilities to integrate, where you don't have to write u's and v's if you can mental math it? Because mental math, u would be negative y, right? What would du be? Or u prime? Is there a negative? So if you're going to put a negative in to be your u prime, you need a negative on the outside. Does it make sense I'm writing negative e to the negative y as my integral for that side? Right? Okay, for this guy, who's my u? Who's my u prime? Or my du? Oh, sweet. Does it make sense? I'm just going to say, oh, hey, that's just u prime. E to the u is e to the u. Plus e. Okay? You can always double check with the derivative. You're doing something. You're probably supposed to be solving or something. Huh? So I divide both sides by a negative. I take ln of both sides. I think I would end up with, let's see, the negative has come over here. Negative e to the sine of x. So negative times a c is an arbitrary constant. We could call it c1, c2, whatever. And then we have to take an ln. Whoa, this just got intense. And then we have to divide by a negative. So y is equal to negative ln of negative e to the sine of x plus c. I'm supposed to be figuring out like an initial condition, y is 0 when x is 0. So I have to take this guy and say, okay, so y is 0 when, and we could do like a negative as a power of 1 over, but it looks bad enough as it is. I might just leave it. When x is 0. Okay, so divide both sides by a negative. Got it. Sine of 0 is 0, right? I need to get rid of the ln to get to my c, so I'm going to have e to the negative 0. But isn't that 1? And then I have negative e to the 0 is negative 1, because anything to the 0 is 1, there's a negative. So c equals 2. So then, Mrs. Leon, I guess they haven't left yet.
No,
So Mrs. Leon, not Mrs. Leon. Ah! It's right there. I can hear it. It's very excited about today. Struggle. Y is equal to negative ln. Lainey, help me out because I don't have the back of the book here to access to. Sine of x plus 2. How are we looking?
Negative e?
Yeah.
Okay.
That's good.
Yes.
Woo, that was a party though. That was a fun one. Why was it so fun? The e to the y and 1 over e to the y you had to change, and I mean there was a lot of places you couldn't do mistakes in this one.
That's so fun.
I thought it was fun.
Well,
Ah! Come on. Whenever you say it was a struggle or it was hard, I say good. That means your brain grew a little bit. If you kept persevering.
I think it shrinks.
Well, it shrinks if it's like meh. Never mind. I don't care. That's like meh. Oh, well, that's a little scary. Okay.
Big brain. Okay.
Anything else in homework? Is that the worst one? Any more odds or evens? I'll take either. Wait, guys, we're seriously good? No odds or evens?
It's too many to ask.
Too many to ask. You're gonna ask me later.
Maybe.
Most likely.
Maybe.
Right.
They're right here.
Open the door.
Just say hi.
They're chilling.
Yeah.
Say goodbye.
Oh.
BC kids watch a video tonight. I have to tell them like directly, even though they should know it. Hey, and I'm talking to you now, and I talked to them in the hallway. It's like this whole time continuum weirdness. Anyway,
I should not have said anything as you watched the video.
No.
Your homework for tonight. What did I say? What did I say to you?
Ooh, I should change it all up.
Yes.
So what kind of teacher has like different information on their Google Classroom and their Venweb and their in-class?
Good one.
Sometimes, but not oh, here we go. Section. Hey,
Am I
there's
right?
a lot of life stuff going on. I don't even know
Am I
what
right?
Here we go. Partial fractions. Partial fractions. We talked about this the other day, and I said it was coming, and it's here. Because, as you guys write down, wait, section 7.5a. It's okay. I just want in your notes, I want partial fractions to be its own thing, because it's going to show up from time to time outside of logistic growth. So I want you to have a section a section on partial fractions, and then 7.5b will be logistic growth. I want two separate titles in your table of contents. Good? Okay. So partial fractions. Another tool that you learned in pre-cal, and technically I could have shown you last year, and maybe I did once or twice, but another way to solve integrals. Wait, why would you use partial fractions on this? Isn't this an arctangent? Why did I say that? Why didn't I say use symbol? Yeah. And why would we even be trying to do arctangent and complete the square? Why not just say the denominators you go for ln? Right, one of you go for ln. What would u prime be? Not there at all, in any way, shape, or form, right? U prime, 2x minus a. So why not complete the square? If you're curious. Because we're not going to. We obviously are supposed to be using partial fractions. What goes wrong? Stuff goes wrong with completing the square, like besides me just not knowing it? Anyway, what else could go wrong besides you just not knowing it? How do you complete the square? We take this guy and what do? Divide it in half because the shortcut for a squared binomial is squared double squared. This is double of, okay, so take half, negative 5 halves. Square it, 25 fourths. Do you want the inside view? Do you see it yet?
Oh.
11 fourths? On the outside. No, this is 24 fourths. Okay, doesn't matter.
Oh, that's a negative.
That's a negative. Why is that bad? This is all fine. I did legal math. It's not that my math is illegal. Why is it bad if I have a negative? What's the formula for arctangent? Yeah, arctangent would need a positive, and yet the positive is not there. So tangent inverse, it is not. Oh my goodness
These middle
gracious.
schoolers. I'm sorry.
Does that make sense? It's u squared plus a squared. Since there is no plus, well, forget arctangent. It's strict. Well, it frankly can't be it. Now, Guys, it looked like an arctangent, and hopefully you would have at least thought arctangent, because sometimes it is. Just this is an impossible arctangent. So what other options do we have? Factor. Because can't I rewrite this guy to be 1 over, hey, factors. You guys mind this, right? What's factors of x squared minus 5x plus 6? -3 and a -2. Some of you would have gone to 6 and 1, but it's impossible for a subtraction because I need same signs. So I need a negative and a negative to get there, so -2 plus a -3. Are we okay? That's just one that might have taken your brains a couple seconds to process, but once upon a time we learned how to see a combined denominator and work backwards to what the partial pieces that would combine would be.
Wait, I bet you can't.
Pause. I haven't broken it up in the sense of just separating it. But I have said you could have come from two of these guys whose numerators I don't know. I'm going to write it in green. Why am I writing it in green? It's green. Now, here's the part. In pre-cal, didn't these get really hard? Like A's and B's and C's and D's and AX plus B and CX plus D, and then we had to like do systems of equations and maybe matrices to solve? Okay. The nice thing is in Calculus BC, I have never seen one get as hard as they have, or they did in pre-cal, which is nice. Because there was a cool trick once upon a time that would help us do some of these a little bit faster and a little bit easier. It's called a thumb trick. And it only worked on the easy ones. The easy ones are the ones that are to the first power with an x to the first power. You guys see how these are both to the first power with x's to the first power? They're called linear factors. The thumb trick did the following. Could be quite nice for you guys to follow along. And for those people who are watching this video, because there are multiple ones of you that are gone, I am going to pretend that this is my thumb. Don't judge. It is what it is. Okay, so this is my thumb. Ready? Thumb trick says, cover a factor. Now, wait a minute, which factor did we just cover? What's the 0 of x minus 3? Cover. 3 is an x, right? Plug it in. What's 3 minus 2? What's 1 over 1? I know A. Thumb trick. You guys forget pre-cal stuff? Yes.
Those two.
Wait, where'd the 1 come from? I covered x minus 3, whose 0 is 3. And then I plugged it in. 1 over 3 minus 2 is 1. Now, what am I going to do when I go looking for his numerator? Cover him. Right, who did I just cover? What's his 0? What's it going to be? -1. See it? Woo! That wasn't that bad. I have not yet come up against an actually, well, that I can see, because I can't see all the multiple choice questions every year. But of the ones I've been able to see of what they've released and their study materials, I have never seen a partial fraction on the BC exam that wasn't that. Now, maybe the numbers weren't one and negative one, but a thumb trick was the way to solve it. Solve it? You're not done. Okay, not the way to solve it, but the way to get the partial fractions. How do I solve it? I could do power rule, but wait, if I make this to the -1, oh, that's going to be like a to the 0 over 0. Wait a minute. What do I do if I have a 1 over u? Oh, and why am I doing 1 over u? Well, because you guys can do this mental math status, right? Because u is x minus 3, and who's du? 1. So are you capable this year of going here? Very carefully, but going here. If u prime was 2, would you put a 1/2? If u prime was 1/2, would you put a 2? How about the next one? Yeah, it'd be minus. Good, because that -1. And your u has a u prime of 1, so it's not a big deal, right? So good. Outline of? Got it. Quotient property. Popping off. Why am I leaving the absolute values? Because those can be negative. If I throw in some x's, I can make it negative real fast. X is 0. Oh, no, that's awesome. Just kidding. How about x is 5? Oh, no, that's positive.
1.
How about x is good? Not 1.
2.
3.
No, third time.
2.5.
Yeah.
2.5 is a positive and a negative. Oh, right. We need the absolute value. How about this guy? How would you integrate him?
What's that problem we did along with?
It was a problem we did a while ago. How do you do this? I'm not going to do the whole thing. Just, is he a partial fractions guy?
We added like, or we subtracted by like something
Well, I think you're making it a little too hard. Just because, have you guys thought about who your u would be if you made, because that has an x in it, right? So who would be your du if this was your u? I don't mind him. I just, isn't it totally legal for me to split up numerators? Why would I do that? This would be a 1 over u times u prime. Wouldn't that just be an ln of? Absolute value is redundant. He's always positive. I have my u and my u prime. 1 over u prime. Are we okay? 1 over u prime. But the 5 needed to be in his own little category because the 5 was not a part of u prime. Oh no. Well, what do I do now? Partial fraction. Wait. Can I factor this guy? Unless you want to do x plus 2i and x minus 2i. I mean, I don't think we want to go imaginary. Well, it would be a u if I had my u prime of 2x, but I don't have a u prime of 2x. I did here. It's great. Here I don't. He doesn't have factors, so he can't be partial fractions. So wait, now this guy's impossible?
And you can't add.
I could, but it won't get me a 2x. I mean, I could do a 2x there and then subtract the 2x there, but then I'm right back to the beginning. See, I show you partial fractions, and all of a sudden you forget the other way. What did we try first? That didn't work over here. Arctan. Oh, it's u squared plus a squared. You silly goofs. It's 5 over 2 tangent inverse. What am I warning you of? How quickly did you forget arctan?
Oh no.
Okay. We have lots of options when we see fractions. Maybe it's an ln. Maybe it's an arctan. Maybe it's partial fractions. We just have to be aware of what we have. Does that make sense? This one, we tried to complete the square because it very well could have been. This guy was an obvious arctan u squared plus a squared. I was just throwing you off with asking you questions about factoring. Because as you do more partial fractions, you might forget about this guy. Don't do that. He's still a guy. He's still helpful. He's still a tool. So is that guy, and so is that guy. Anyway. Bum-ba-da-dum-bum. Let's keep going. Now, partial fractions. I'm doing a quick little pre-cal review, just in case. Just in case. I just said I've never seen a BC exam without, or where a problem needed more than the thumb trick, as far as partial fractions. But all that to say, maybe we should still review the pre-cal. So, real fast, one page, like boom, there it is. Pre-cal. Did you guys realize a second ago I just said that something, when we were doing homework questions, I was on the wrong page? I said something was top heavy. It was like an x cubed over an x squared. Do you see how number 1 is talking about top heavy stuff? P.S. That number 7 I looked at was a circle problem, which means it's a homework problem for tonight. What do you do with top heavy things? No. Division makes it all better. Yes. Okay, top heavy. That means the degree of the top is, wait a minute. It didn't look top heavy though, did it? Hold on, I want you to keep taking notes. I'm going to go find it. I mean, like, there was 2 terms on the bottom, and there was 1 term on the top. Like, if you were just looking at it from way zoomed out, doesn't it look like a normal fraction? Like something over something minus something? Yeah. Looks kind of normal, right? What made it top heavy? Just kidding, that's not what we're looking at. I mean, it is, eventually. What made it top heavy? It was a cubed over a squared. It's top heavy. What does that mean? It's improper. No. Improper. It doesn't make any sense. Improper numbers. Oh. What's going on with improper fractions? What's 12 over 5? I'm giving the pre-cal kids unit circle quizzes right now. Unit circle quizzes, if you saw cosine of 12 pi over 5, you'd freak out because it's an over 5. But still, what quadrant would you put 12 pi over 5? Don't you have to think of mixed numbers at least to some degree? Unless you're totally cheating and you're saying like, oh, it's cut into fifths, so 5 and 10 and 15. Oh, no, and 2. Okay, unless you're thinking in fifths. Wouldn't you think something about like 2 and a little bit? 12 over 5? 2 5s go into 12 and there's 2 remaining. You have to divide in order to figure out what's really there. Same thing with polynomial expressions that are top heavy in integrals. You guys see there's an example just waiting to be solved in a smart notebook that's not responding? There we go. And you can do it. What if I asked you to integrate that? Arctangent! Oh, I hope not. Not unless square root of x is my u, but I don't have a 1 over 2 square root of x somewhere else for a u prime. Partial fractions? You can't factor that. ln. 1 over u times u prime doesn't work? Ah, okay, what do? Not arctan. Not ln. Not partial fractions, which are still technically ln. You say? It's top heavy. Well, it doesn't look top heavy. There's well, the degree on top is higher. Guess what, guys? This is some sort of linear something. No, it's not a linear something. Yeah, it is. It's a squared over. It's a linear something. If you divide, let's figure out what that linear something is. It'd be a lot easier to integrate a linear something than that weird rational something. So x goes into x squared how many times? Don't I have to distribute? Oh no, there's an extra piece. Oh, there almost always is with improper stuff. We just make them remainders. So x squared minus x squared, don't forget to distribute. Don't kill that seal. It's a negative x. What does that mean? Wait a minute. Doesn't this go into this? It would still be top heavy. They're tied. You can still keep dividing. How many times does x go into negative x? Negative once? There we go. Negative once. So that'd be negative x. Remember they need to cancel. And then minus 1. Negative 1 over x plus 1. 0 minus a negative 1 would be a remainder of 1, right? And don't remainders, don't I just make them little fractions? Which would you rather integrate? This guy or this guy? Hopefully we all have the same answer. Which one would you rather integrate?
Option B.
Exactly. Whenever you see someone who's top heavy, go divide. The only way to go. Usually it's the only way to go. A creative u sub is going to get you in a world of trouble. So, oh, the integral of x, that's just x squared. Over 2. Integral of 1, that's just x. Integral of this guy. Aha! There was an ln. Okay, but there was a lot more than an ln, right? And it wasn't, well, it was of who you thought it was, but would you have gotten the rest of it? Top heavy, improper. The degree on the top is greater than the degree on the bottom. What's the very first thing you should do? Now, why am I showing long division and not synthetic? I can't guarantee this guy is going to be a nice little linear factor that could have been put in the box. Remember that number 7 that I accidentally went to that's going to be a great, or is serving as a great example for today? Could you have put this in a synthetic division box? Not all at once. You could have made an x plus 2 and an x minus 2. But, long story short, divide. Everything gets easier. Whenever you have someone that's top heavy, divide first. Okay, if we get through that though, what if we have divided? What if we have divided? I do say think arc trick. I have said, okay, just make sure it's not arctangent because that one was. Make sure it's not arctangent. But if it's not arctangent and you trying to get to ln, straight to ln isn't working with du's, you have too much or you have too little, all right, then try factoring. When you try factoring, you're going to get linear ones, but there's x to the 1s. Maybe you'll get quadratic ones, like x squared plus 4. You couldn't have gone down anymore. Are you sure you thought about arctangent? Okay, but if you're stuck with guys and there's no other way to go, well, the long way of doing it, no. It's because I said hi. The long way of doing it, there is a way, and I'm going to go ahead and show it just so it's in your notes online, but the thumb trick is the way to go for all of these. There is a long way for this one and this one, but it's not necessary. You guys get out of here, it's totally fine. I think you guys just saw me point to homework. It starts with integrals, so don't go beyond that. Don't go to the word problems, but play with the integrals. Sound good? Maybe they need partial fractions. Maybe they're just arctangent. Maybe they're ln. See what you can do with the beginning of homework, and I'll see you later. Yeah, I just
Did you get invited to the different one? No, I just turned over a trash
Now
can.
I'm serious. I had it.
The bonus.